Welcome back to Teen Tutors. We're glad you're joining us. In today's video, we are going to be covering Unit 7 of AP Calculus AB, which is differential equations. So we're going to be covering differential equations, particular solutions, as well as slope fields. And we're going to do 2 FRQs on differential equations and slope fields to help you understand it a little bit better. Now, before we start the video, make sure to print out the guided lecture notes in the description so that you can follow along as I teach. Without further ado, let's get into the video. Okay, so let's talk about differential equations. So given dy dx, which is just f prime of x, we can find f of x using differential equations. So instead of talking a lot about notation, I'm just going to explain this a little bit, and then we're just going to jump straight into examples. So basically, we can solve for f of x if we're given dy dx by doing the following. So we need to get some function of y times dy equal to some function of x times dx. Okay, so in this example, for example, we can rewrite this as y dy equals 6x minus 7 dx. So we just have to manipulate the terms so that we can get a function of y and a function of x. And then we just integrate both of them, right? So we're going to have 1/2 y squared is going to equal 3x squared minus 7x. And then we need to add a plus c only to one side, because if you have a c on both sides, that's the same as just saying it's a c on one side, because we don't know what that c is, right? Instead of like having a +1 and like a -2 here, right? I could just put a -3 on the right side. Is basically what only having a plus c on one side means, right? So then now let's find y. So we can say that y is going to equal 6x squared minus 14x, and then again plus c, because 2 times a constant is still some constant that we don't know, right? And this should be y squared, right? And then to find y, we would square root both sides. So we could say y equals plus or minus the square root of 6x squared minus 14x plus c. All right, and then in this example, we have dy dx equals y minus 7. So your first instinct might be to add a 7, but we can't do that because we want to use multiplication and division here, okay? Because we want to leave this as its own function. So let's say 1 over y minus 7 dy equals dx, right? And then now if we integrate both of these, we're going to get ln of y minus 7, and that's going to equal x, right? X plus c. Right, so then we can get y by itself by using e on both sides, and we're going to get y minus 7 equals e to the x plus c. But what is this equal? This is equal to e to the x times e to the c. And what does c equal? That's just some constant. So we can actually just say that y minus 7 equals ce to the x, okay? And then we can finally say y equals ce to the x plus 7, right? So 2 more examples. We have solved the differential equation xy plus dy dx equals 100x. So we can then say that dy dx is going to equal 100x minus xy. We can then factor out an x and say dy dx is going to equal x times 100 minus y. Then we can say 1 over 100 minus y dy is equal to x dx. Integrate both sides, and we're going to get negative ln of 100 minus y equals 1/2 x squared plus c. Then we can say that ln of 100 minus y is going to equal negative x squared over 2 plus c. And then what we could say is we can use e, right? And it should look like this. So we can then use e and say that 100 minus y equals e to the negative x squared over 2 plus c, which equals ce to the negative x squared over 2, right? So we can then say that 100 minus ce to the negative x squared over 2 is going to equal y, right? So then now in this question, we have 3y minus 10xy plus y prime equals 0. Recall that y prime is the same as dy dx, okay? So this would be like saying, we could then say that dy dx is going to equal 10xy minus 3y, right? So then we can say that dy dx looks like we could factor out a y, right? So we could say y times 10x minus 3, right? And then you can say that 1 over y dy equals 10x minus 3 dx, right? If you integrate then both sides, you're going to get ln of y is going to equal 5x squared minus 3x plus c. Then we can use e, and we can say that y equals e to the 5x squared minus 3x plus c, which is then equal to y equals ce to the 5x squared minus 3x. Now, before I start talking about particular solutions, a staggering 98% of viewers to this channel are not subscribed. So make sure that if you find content like this helpful, you subscribe to the channel so that you don't miss out on any future unit reviews or any FRQ or multiple choice practice videos that we will be releasing throughout the month to help you prepare for the AP exam. Okay, so let's now look at particular solutions. So if we are given dy dx and a point of f of x, we can find what our value of c is, okay? So in these questions, what we're missing to get rid of this c is we're not given a point on f of x. So we're gonna have the same exact solutions here, except what we're gonna do is then we're gonna plug in this value and just find c. So here we have dy dx equals y minus 4xy. So what we would do here is we're just going to then say, okay, let's factor out a y. So we'd have dy dx equals y times 1 minus 4x. I could then say 1 over y dy equals 1 minus 4x dx, right? And then now if I'm going to integrate both sides, I'll get ln of y equals x minus 2x squared plus c. So we could say that y equals ce to the x minus 2x squared, right? Then what we could do is we're going to plug in the point 0, 7, and we're going to get that 7 equals ce to the 0 minus 2 times 0 squared, which is just equal to ce to the 0. So if 7 equals ce to the 0, well, what is e to the 0? That's just equal to 1, so that would equal c times 1. So if 7 equals c times 1, then c is going to equal 7, and therefore we can say y equals 7 times e to the x minus 2x squared, right? Now in this example, we have dy dx equals sine of x over y, right? So I'm going to say y dy equals sine of x dx. If I integrate both sides, I'm going to get 1/2 y squared equals negative cosine of x plus c. Then I am going to solve for y. So I'm going to say y squared equals negative 2 cosine of x plus c. And then we could say y equals plus or minus the square root of negative 2 cosine of x plus c, right? Now I'm given the point pi comma 4. So be careful, we need to use the positive square root because 4 is positive, so y needs to equal a positive square root. So we're going to say 4 equals the positive square root of negative 2 cosine of pi, right, plus c. So that's going to be 4 equals the square root of negative 2 times cosine of pi is negative 2 times negative 1, so 2 plus c. So we could say 16 equals 2 plus c if we square both sides, so c equals 14. So we would then write this as y equals the square root of, we would have negative 2 cosine of x plus 14. Okay, so let's look at an FRQ example. It is extremely likely that you will have an FRQ on differential equations, okay? I think it's something like 8 out of the last 10 years there's been a differential equation FRQ or something of the sort. It is extremely probable that you will have an FRQ on this. So let's take a look. We have a medication is administered to a patient. The amount in milligrams of the medication in the patient at time t hours is modeled by the function a of t, or y equals a of t, that satisfies a differential equation dy dt equals 12 minus y over 3. At time t equals 0 hours, there are 0 milligrams of the medication in the patient, and then we're asked B, C, and D. I've skipped A because we're actually going to cover that in the next part of this video. So B says, using correct units, interpret the statement of limit as t approaches infinity of a of t equals 12, right? So that would just be as t approaches infinity, so as time goes on forever, right, until infinity, our y value is going to approach 12. So what is our y value? Well, or our a of t we could call, that is going to be the amount of milligrams of medication in the patient, right? So we could say that for B, as time goes on, we can say the amount of medication in the patient will approaches 12 milligrams, right? Something very simple like that. Okay. Now, for part C, what are we asked? We are asked to use separation of variables to find the particular solution to dy dt equals 12 minus y over 3 with initial condition a of 0 equals 0. So dy dt equals 12 minus y over 3, and then we're given the point a of 0 equals 0, right? So let's now use separation of variables, right? So I can say that, how about 1 over 12 minus y dy is going to equal 1/3 dt, right? So now I can integrate both sides, and I'm going to get negative ln of 12 minus y is going to equal 1/3 t plus c, right? So I can then use e. I can say that, or first let's get rid of this negative, right? So I'm going to get ln of 12 minus y is going to equal negative 1/3 t plus c, right? And then I can now use my e. So I'm going to say 12 minus y equals e to the negative 1/3 t plus c, which is equal to ce to the negative 1/3 t, right? So then I can say that 12 minus ce to the negative 1/3 t equals y, right? So then how do we find c? Well, we're going to plug in the point 0, 0. So we're going to say 12 minus ce to the 1/3 times t, which would just be 0, equals 0. So 12 minus c equals 0 because e to the 0 is just 1. So c would equal 12. So our answer then would be, we would then get that 12 minus 12 e to the negative 1/3 t equals y. And we could also write that that equals a of t, either one. Okay, so let's continue on to part D. Okay, so part D says, a different procedure is used to administer medication to the second patient. The amount in milligrams of the medication in the second patient is modeled by y equals b of t. That satisfies dy dt equals 3 minus y over t plus 2. We're told at time t equals 1 hour, there are 2.5 milligrams in the second patient. This gives us the point 1, 2.5. And says, is the rate of change of the amount of medication in the second patient increasing or decreasing at time t equals 1? So what are we actually being asked? Okay, we are being asked for the double derivative, because if we're asked for the rate of change, that is f prime. But the rate of change increasing or decreasing, now we're asked for f double prime. Now we're being asked for concavity. Technically it's b, right? So we need to find the double derivative here. So we're given, let me just write down here, that dy of dt equals, we would have, what was it up here? It says dy dt equals 3 minus y over t plus 2, and we're given the point at 1, 2.5, right? And so let's now differentiate this. So we're going to have to use implicit differentiation here, right? So we would have d squared y of dt squared is going to equal 0 minus, we're going to have to use quotient rule here. So we're going to have 1 times dy dt, because the derivative of y with respect to t is 1 dy dt, and then times t plus 2, and then we're going to have minus y times just the derivative of t plus 2, which is 1, over t plus 2 squared. So now the problem is, what is this derivative? What is dy dt? Well, we can then just plug in our points to this, right? So dy dt evaluated at 1, 2.5, so you could write that, would equal 3 minus 2.5 over 3, which it looks like that's going to equal 9 minus 2.5 over 3, which would then equal 6.5 over 3, right? So let's now plug that in. So we have d squared y of dt would equal negative, we would have 6.5 thirds times, we would have t plus 2, which is going to be 1 plus 2, which is 3, minus, what is our y value? It's going to be 2.5, right? And that's going to be over, this should be in brackets, and that's going to be over t plus 2 squared, which is just 1 plus 2 squared, or 9. Okay, so then we're going to have negative, these 3's would cancel, and we would get 6.5 minus 2.5 over 9, which equals negative 4/9. Okay, so since b double prime is less than 0, so b double prime of t is less than 0, so we would say that, and I should actually say at t equals 1, so the amount of medication is decreasing, we could say. The amount of medication is decreasing. And you could add a little more to this. The amount of medication is decreasing. You could technically write that d squared y is continuous and it contains the value t equals 1. If you put something like this, you are definitely going to get that point. Your reasoning also kind of includes that that mathematical solution, right? So let's now talk about the second part of this unit, which is slope fields. Okay, so slope fields are basically just a graphical representation of derivatives of a function at a given point. So you learn this in Calc 1. Once you go to Calc 3, you'll learn about vector fields. But for now, it's basically just we are going to take the derivative of a function, and usually they actually give you that derivative, and then you are just going to plug in some points and find what the what the slopes are. So let's plug in some points. So let's plug in the point. Let's just look for 0, this one. Let's make 9 points. So at the point 0, 0, what is dy dx? Right? It looks like dy dx is going to be 0. So we would just have a straight line. Right? What about the point of, let's do 1, 0, right? That's going to give us 1. Right? So we're just going to have a line going through that point with a slope of 1. Now what about the point 1, 1? Right? Well, that's going to give us a 1 plus 1, which is 2. So we're going to have a line that goes through the point 1, 1 with a slope of 2. So it's got to be a little bit more, right? And then we would have, let's say, the point 1, 2. That would give us 3. So we'd have an even steeper slope. Let's just make it look like that, right? And then now let's look at our zeros. So we already did 0. So now 0, 1, that would give us 1. So we're going to have, say this is our slope. And then 0, 2, that would give us a slope of 2, so a little more. All right, and then now let's look at negative 1, 0. So that'd give us negative 1. So we're actually going to have a negative slope here. And then negative 1, 1 would give us a slope of 0. So just a straight line out. And then finally, if we plugged in negative 1, 2, we're going to have a slope of 2, or a slope of 1. So it's going to look like this. Okay, so that would be our slope field. Now here we're asked to create the slope field for x over y plus 1. So at the point negative 1, 0, let's start out at, we're going to have just 0, right? Or actually, we're not just going to have 0. We're going to have negative 1 over 1, so negative 1, right? So let's draw it like this. Now at the point, let's pick negative 1, 1. We're going to have negative 1 over 2, right? So it's going to be a little less steep, but it's still going to be negative. So let's make it look like that, I guess. And then now, how about negative 1, 2, right? We're going to have negative 1 over 3. So that's going to be even less steep. So, right, like that. Now let's pick another point. Let's pick 0, 0. That's going to give you 0 over 1, which is 0. Okay, what about 0, 1? Right, that's going to give you the point 0, or 0 over 2. Right, so again, 2. So 0. So then we're going to have 0, 2, and guess what? We're going to get then 0 over 3. So it's also 0. So then we take a look at, let's pick 1, 0. That's just going to give you 1. So look like this. Then 1, 1, that's going to give you 1/2. So a little less steep. Make it look like that. And then 1, 2 is going to give you the slope of 1/3. So that's even less steep, right? So again, all you have to do is you find these points, you find the slope at that point, and then draw a small little line, even like a tick, with a slope of what you found given the derivative. So now let's look at this question. We want to match the following slope fields with the correct differential equation. Okay, so let's take a look. Usually you're going to take a look at a pattern that you can recognize. So let's take a look at y over x. Okay, so what we could just do is, again, just plug in some points. So for y over x, right, we would plug in, let's say, well, first of all, we could plug in numbers, but actually when I'm looking at this, I'm thinking, okay, well, as I go outwards from the graph, right, if I'm going in the straight line of y equals x, my graph is just going to look like this, okay? And then my graph's also going to look like this, coming this way, right? So what is the only graph here that does that, right? That's 1. And also, how did I figure this out? Well, if our y and our x equal the same amount, well, then our slope is just going to equal 1, right? Here our y and our x equal the same amount, but x is negative, so it's going to be 1 but negative. Here they're both negative, so it's 1 but positive, and here one of them is negative, so it's 1 but negative. And this is the only one that has values that are radiating outwards, right? We see that those straight lines coming this way in this slope field and not any of the other ones. Okay, so let's now look at B. So we have dy dx equals sine of x. So here we literally just have to say, okay, Well, if dy dx equals sine of x, I know the graph of sine of x, right? So it would literally just look something like this, right? And it is only dependent on the x value, so it's just going to look like everything's on top of each other, okay? So it's going to just be our 3, right? So a is going to match up with 1, b is going to match up with 3. Now we have dy dx equals x plus y. Okay, so here what we would have is as our x increases, so does our dy dx. So if we look at our two numbers that are left, if our x decreases, so as x goes up, dy dx goes up, right? And it should be the same for the y. As the y goes up, dy dx should go up, right? So out of our two remaining options, so let's take a look at 2. If our x is going up, is our slope increasing? So it looks like it is, right? It's getting steeper and steeper and steeper, right? Now, for our y value, it should be the same. So as our y increases, it does look like we are going to get steeper and steeper and steeper. So that would make sense. And then if we do look at C, that's not the case, right? Here we have, it looks like a circle, right? So that's not going to be the case, right? It actually looks like it's just dependent on our y values. Okay, so that's not going to work. Okay, so C equals 2. So now finally, why would D equal that? Well, I'm going to do this by saying, okay, every time our x equals 0, we're just going to have a straight line of 0, right? So if I draw this in a different color, if our x equals 0, we're just going to have a straight line of 0, right? And if our y equals 0, so if y equals 0, then we're going to have a straight line of infinity, right? So when y equals 0, we're going to have a straight line of infinity, right? So what's the only graph that does this? It's this one, right? When y is 0, we have a straight line of infinity, right? And when x is 0, we have a straight line this way, right? So our answer there would be 4. Okay, so let's now take a look at another FRQ here. So we have the 2022 FRQ. So what you're going to notice is that usually the FRQs for differential equation might also have a slope field. So usually if you have a slope field, it's pretty much a gimme. So we're told, consider the differential equation dy dx equals 1/2 sine of pi over 2x times the square root of y plus 7. And let y equals f of x be the particular solution to the differential equation under the initial condition f of 1 equals 2. So this looks exactly like a particular solution differential equation. And then we're asked the function f is defined for all real numbers. And first we're asked a portion of the slope field for the differential equation is given below. Sketch the solution curve through the point 1, 2. So what is this solution curve saying? Well, this basically just means that what we're going to do is we are going to take the point we're given, so it looks like they actually give that to us, and just draw through the slope field that we're given and follow the path, right? And this would be good enough. You do not have to draw exactly on the lines, okay? You just have to show that you understand what you're doing, right? So then part B says, write an equation for the line tangent to the solution curve in part A at the point 1, 2. Use the equation to approximate f of 0.8. So for B, it looks like we're going to be using linearization. So we're going to have to say y minus y1 equals m times x minus x1. So what is our m? Well, remember that m equals dy dx, right? So if our dy dx equals 1/2 sine of pi x over 2 square root y plus 7, then we can plug in our point of 1, 2, right? So we could say that m equals 1/2 sine of, we would have pi over 2 times the square root of 2 plus 7, so square root of 9. So we would have, what is sine of pi over 2? It's 1/2, or it's just 1, times that 1/2, you would get 1/2. So you'd have 1/2 square root 9, which would give us 3/2, right? So then what you could do is you would say y minus our y1 is 2 equals, we would have our slope is 3/2 times x minus 1, right? So that is our equation, but now we have to actually use this to approximate f of 0.8. So how would we do that? Well, we could just say that y equals 3/2 times 0.8 minus 1 plus 2, right? So it would be y equals 3/2 times, it looks like it's negative 2 over 10 plus 2. So we'd say that equals negative 6 over 20 plus 2, which would equal 2 minus 0.3, right? So it would equal 1.7. right? So now if we look at C, that says it is known for that f double prime of x is greater than 0 for negative 1 to x to 0 is the approximation found in part B in overestimate or underestimate. So this is a question on concavity, okay? So if f double prime of x is greater than 0, we could draw that f of x might look something like that, okay? Again, it doesn't actually have to look like that. It could be an exponential function. It could be like this, but this is an example of a concave out function. So I'm just going to draw it like that. That's what you want to get into the habit of when they ask you something like this, right? And so is the approximation overestimate or underestimate? Well, so if we then write that for negative 1 to x to 2, the approximation looks like it's going like this, right? Then what would happen? Well, then our answer for f prime of 0.8, which is inside of this value, the tangent line is going to be under the graph, right? So you would just say underestimate. So you would say underestimate, and we could say that, let's say, since f double prime of x is greater than 0, then the function increases faster than the slope of the tangent line, or something like that. Tangent line. You could write something like the slope will become greater than the tangent line, or something like that. That would honestly probably be better. The slope will become greater than that of the tangent line. Okay, so let's then look at part D. So part D says, use separation of variables to find y equals f of x, the particular solution to this differential equation. So let's again write. So it was what? dy dx equals, let's just get this written down, 1/2 sine of pi over 2x times square root of y plus 7. Okay, so it looks like we could then write that, so we could write 1 over y plus 7 to the 1/2 is going to equal 1/2 sine of pi over 2x, right? So, and then we would have a dx, and there should be a dy here. That's the whole point. So then we need to integrate both sides. So what would be the integral of this? Well, so let's rewrite this as y plus 7 to the negative 1/2 dy, and that's going to equal the integral of 1/2 sine of pi over 2x dx, right? So then we could say, okay, well, this will be y plus 7 to the 1/2, and we have to multiply that by 2 to offset it, right? So we get that, and that's going to equal, it looks like we'll have here a cosine, right? It will be a cosine and a pi over 2x. And so what would we get when we do chain rule here? Well, we're going to get pi over 2. So it looks like we have to do a 1 over pi to offset that, and then make sure you put that as negative. We covered this we covered integrating these two types of functions in our video on integration, right? So if you are confused on how to integrate this, make sure to check out that video. Now we would have a plus c here. So we would then write that, okay, well, let's solve for y, right? So we could say that 2 square root y plus 7 equals negative 1 over pi cosine of pi over 2x plus c. And what I'm actually going to do is I'm going to solve for c and then solve for y. Either way works. In the previous examples, we solved for y and then we got c, but either way works. So let's plug in the point that f of 1 equals 2. So we're going to say 2 root 2 plus 7 equals negative 1 over pi cosine of, we would have just 1 pi over 2 plus c, right? So we're going to have 2 root 9 equals negative 1 over pi cosine of pi over 2, which is going to be, cosine of pi over 2 is 0, right, plus c. So we're going to have 2 square root 9, which is 6, and that equals c. So great. Now we have that 2 root y plus 7 equals, we would have negative 1 over pi cosine of pi over 2 plus c, or plus 6 now, right? So then how could we solve this for y? Well, we could then say that y, square root y plus 7, is going to equal negative 1 over 2 pi cosine of pi over 2 plus 3, dividing both sides by 2. Then we can square both sides. We could say y plus 7. I'm going to actually put the 3 in front. So it's going to equal 3 minus 1 over, there should be a 2, minus 1 over 2 pi cosine of pi over 2x, right? There should be an x here. And then finally, we can just subtract a 7, right? So we could say y equals 3 minus 1 over 2 pi cosine of pi over 2x squared minus 7, right? So that would be our answer. So that is it for our lecture on Unit 7 of AP Calculus. Make sure that if you found this video helpful, you subscribe to the channel so you don't miss out on our future uploads that are going to help you score better on your AP exams. Now, if there's anything you still are confused about, make sure to comment down below so that we can clear up any confusion that you have. Thank you for watching, and as always, we'll see you in the next one.